Very good. So what's going on with 65 and t? What operation is going on there? Grace? Multiplication. So in order for them to be multiplied by each other, right? 65 needs to represent the number of voters that registered each day during the drive, right? Because t is the number of days after the drive began. So the only answer that included the number of days or the number of voters each day was D. So that's why it's the answer. Now, what does 3,450 represent? What does 3,450 represent? Isabella? It is the total, but at what point? It's the total at what point? Gio? Nope. In the beginning. Okay? Because what if t was 0? If t was 0, that means that there's 0 days, right? So that's before the drive began. What's the total number of voters? 3,450, right? Because if t is 0, doesn't this whole term go away? Yeah. So the voters is 3,450, okay? So this is our starting number. And then after that, we've got 65 voters per day. Okay, so after 1 day, you would add 65. After 2 days, you would add 2 times 65, so on and so forth. We're going to start, what I want you guys to do next to that warm-up in that top right corner where there's some space, okay? Write out these expressions, okay? We're going to write out 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st power, 2 to the 0 power, 2 to the negative 1 power, 2 to the negative 2 power, 2 to the negative 3 power, and 2 to the negative 4. Yes, write them all down, okay? You just call me crazy?
Yeah, I heard that.
Good. I like being crazy. Okay. There's only 9 of them. Calm down, okay? All right. So, who's familiar with exponents already? Brady, what does an exponent mean? Excellent, okay? So Brady said we are taking the number, which is the number down here, and we're multiplying it by itself, the number of times that our exponent is, okay? Circle that 4 in a different color, and write, this is what we call our exponent, okay? Okay? What is the 2 called down below? The base, very good. The 2 is what we call our base, okay? So how an exponent works is it says, okay, take your base and multiply it by itself the number of times that you have your exponent, okay? So since our exponent is 4, we're going to write 2 times 2. That's 2 times, then 3 times, and then 4 times. So 2 times 2 times 2 times 2, and then we're done, okay? Now 2 times 2 is 4, times 2 is 8, times 2 is 16. Hey, what's up? Yeah, you can go. Okay. Now, if we continue this pattern, right, we would get 2 times 2 times 2 for 2 to the 3rd. What is 2 to the 3rd? 8. Then we would get 2 times 2, which is 4. If we keep going, what would be 2 to the 1st power? 2. It's just 2. Now, watch what's happening to our values. We went from 16 to 8 to 4 to 2. What's going on over there? Amina? It's counting by 2s. They're dividing by 2, right? So if we kept going, what should 2 to the 0 power be?
0.
What's 2 divided by 2?
Oh, 1.
1. Okay? And if we kept going, right, what would be 1 divided by 2? 1 over 2. What would be 1/2 divided by 2? Oh, who said that? 1/4. And if we kept going, what would be 2 or 1/4 divided by 2? 1/8. What would be 1/8 divided by 2? 1 over 16. Now, take a look at the positive exponents. And someone make a connection here. How do those positive exponents compare with their negative exponents? Nick? They're reciprocals, okay? Those are the first two properties that we're learning today, okay? The first property is that any number raised to the 0th power will always be 1, and any number with a negative exponent is just the reciprocal of its positive exponent, okay? So let's see how that works, okay? So any number that you raise to the 0 power will be 1, as long as that base is not 0, okay? Because 0 raised to the 0 power, guys, nobody's figured that out. We leave it as undefined in math, okay? Yes? When Aiden comes back, okay? Actually, Jonathan's next, then when Jonathan. Okay, so you can say that A being any number raised to the 0 power is 1, as long as A is not 0, okay? Are we Gucci here? So what's 7 raised to the 0 power? 1. What's X raised to the 0 power? 1. What's Y raised to the 0 power? 1, okay? Now, negative exponents, okay? So let's say we had an integer n and any non-zero number, A, raised to that negative n, okay? A to the negative n is the reciprocal of A to the n, okay? So if we have 4 to the negative 2, right? That is the same as 1 over 4 squared, okay? 1 over 4 to the 2nd power. What they did was 4 to the negative 2 power, right? Is the same as 4 to the negative 2 over what? What can we always put underneath here? 1, right? Between this and this, what changed, guys? It switched the exponents from positive to negative. What else switched? Brady? It was the reciprocal, okay? So how I like to think about it, if you flip this 4 to the negative 2 over the fraction, make it a positive exponent, okay? Same thing over here. A to the negative n, right, is the same as 1 over A to the positive n, okay? Anytime you flip that exponent over the fraction, it becomes positive, and vice versa. What would happen if we had 1 over A to the negative n? If we wanted it to be a positive exponent, how could we write that? Brady, what do you think?
Oh, it's a positive.
Rihanna?
Flip it over.
You would flip it over. What would it become?
N over 1.
Perfect. Which is the same as just A to the n. Okay? So it works in both directions, right? If you have a negative exponent, think about that as a fraction and just flip it over. Okay? All right, let's take a look at our first few examples. Okay? A. Now, in these examples, we need to evaluate each expression. Okay? 6.7 to the 0th power. 1, always, okay? Unless your base is 0. Yep. 0 to the 0 power is? It's not 0. Undefined, okay? We don't have a term for it. It's undefined. All right, moving on. B. What would negative 2 raised to the negative 4 power be? Nick?
1 over 16.
Okay, hold on. You're jumping ahead. I love that you said 1 over. It's going to be 1 over what, Gio? Excellent, okay? So we flipped this over 1, right? And what did we change? The sign of our exponent. Do you guys all see that? Okay? So we changed the sign of our exponent. We put it over 1 or underneath 1, right? We're flipping it over the fraction. And now, Nick, we can go ahead and multiply negative 2 by itself how many times? 4, right? So this is going to be 1 over negative 2 to the 4th power is going to be negative 2 times negative 2 times negative 2 times negative 2. Well, what's negative 2 times negative 2, guys? It's positive 4. And then if we do it again, It's negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is going to give me positive 4. So it's 1 over 16.
So practically, you get like, if you
Basically, this
get a negative number to a power, will it just turn positive?
Ah, that's a great question. So let me repeat your question, Grace, okay? Because I love that question. Grace asks, so if we have a negative number as our base, right? And we're raising it to a power, will we always get a positive result? Now, it's true for certain numbers. Does anyone have an idea of what numbers will always, as an exponent, will always give us a positive result? Aurora? Even numbers, okay? Now, if it's a negative base and it's an odd exponent, what's our result going to be? Negative, okay? Because you see how we had 4 negative values, right? We had negative 2 4 times, so 4 negatives. Don't a negative and a negative cancel? So as long as your exponent is even, they're all going to cancel, right? But if we added one more, what would our result be? Negative or positive? It would be negative, okay? So if you have an odd exponent, it's going to be negative. If you have an even exponent, it's going to be positive. Great connection, Grace. Amina, what's up?
What if you just knew how to do that? Would you have to write all of that out?
Yes, I would expect you to write all these steps out, okay?
Yeah, to show our work culture. What if we just know that from if it's a simple number, we don't have to write anything out?
Give me an example of like a simple number. Question, moving on. C, negative 9 raised to the 0 power.
One.
It's just 1, okay? Now, underneath this, I need you to write another example because this is completely different. What if we had negative 9 to the 0 power? And I'm going to tell you straight up, it's not 1. What do you think it is, Nick?
negative.
It's negative 1, okay? Now, let's take a look at why it's negative 1, okay? The parentheses up here, okay, in this first problem tell us that our base is not just 9, it's negative 9, okay? Now, when we don't have parentheses, guess what our base is down here? It's positive 9. That negative is kind of just stuck on there at the end. So if you're raising 9 to the 0 power, you get 1, right? But only this part is 1. You still have your negative, right? Up here, we were raising negative 9 all to the 0th power, which will automatically give us 1, okay? But down here, you're only raising 9 to the 0 power, okay? Which gives you negative 1. Yep.
So what happens if it didn't have the parentheses?
So if it didn't have the parentheses like this, your answer would be negative 1. Okay? Now, if it helps you, right? Just put parentheses around whatever number is immediately next to the exponent, right? If you don't see parentheses, you can add in your own. Just make sure you only include the number that's right next to it. Don't include a negative sign. Don't include like an X term. Don't include anything else but the number that's right next to it. Got it? Okay. Let's do this one. 3 raised to the negative 3 power. Aurora, what do you think? Good. How'd you get that?
I just did 3 times 3 times 3, and then I just put 1 on.
Yeah, so it's going to be 1 over 3 to the 3rd, right? Because we had a negative exponent. And then she did 3 times 3 times 3. So this is 1 over 3 times 3 times 3, which is 1 over 27. All right, questions so far on A through D? Are we keeping up? Okay, let's talk about when there's variables, okay? That's like X, Y, Z, all those beautiful ones, okay? Now, when we're talking about exponents, okay, and with variables, in order to be completely simplified, right, we need to have only positive exponents, okay? Only positive exponents. So if you have a negative exponent, you have to change it so it's a positive exponent. Let's take a look at the first one, okay? We've got 4x raised to the 0 power over y to the negative 3. Let's start with the numerator, okay? In the numerator, what can we simplify?
4.
So the 4 is going to stay there. Okay, we can definitely do the x. Now, what's the base for this exponent of 0? Be careful here. What is the base of the exponent 0? Gabby?
4.
No,
X. 4.
it's just x. Okay? Now, if it was 4x, there would be parentheses around here. Okay? But remember, I told you what? If there's an exponent with no parentheses, what becomes its base? Just the term right next to it. Okay? So the x is our base. And if we took x and we raised it to the 0 power, what would we get? Good. So it's 4 times 1. Because x to the 0 is going to become 1. Over y to the negative third power. Now guys, what's 4 times 1? It's just 4. So this is 4 divided by y to the negative third power. Now, from here, we're almost completely simplified. But what can't we have? What did it say in the beginning that we can't have? Brady? Or we can only have what? Positive exponents. So how can we change that y to the negative third power to a positive exponent? What was that? Reciprocal. Very good. So in other words, we're going to move this from the denominator to the numerator. Okay? So when we do that, just change the sign of your exponent. Don't change anything else about it. So we've got 4 times y to the what power now? Third power over 1. Do we need to put it over 1? No, because that's dividing by 1 is just making it the same thing. So this is just 4 times y to the third.
Wait, that's the answer.
Yep, this is the answer. Sure, Brady. Oh, wait. Who was next? All right, let's do the next one. Let's do B. All right, I'm going to tell you guys, you have to be careful here. What is the base of the exponent 0? What is the base of the exponent 0? Liz? 5. Not negative 5, okay? So if we're taking 5 and we're raising it to the 0 power, what am I going to get? If we're taking 5 and raising it to the 0 power? 1, okay? So this piece is 1. So in my numerator, what do I have? Negative 1, okay? Do you see how just this piece is 1? But there's still that negative outside, okay? Over 2 to the negative 2 power. So what can I do now? Nick?
Make it a reciprocal so you have negative 1 times 2 to the second power.
Good. Negative 1 times this negative 2 means that we're going to move it to the numerator and change the sign of the exponent. So it's going to be, I'm sorry, did I say negative 2? Whoops. Change that. This is going to be negative 1 times 2 to the second power. What's 2 to the second power, Nick?
4.
Yep, so this is negative 1 times 4, which is negative 4. So we're going to take a look at C. We've got 3 to the negative 2, x to the negative 5, all over y to the 0. What do you guys think I need to do? Aurora?
I would just make y 1. I mean, like the bottom 1.
Good, okay? So we're going to say, all right, this is 3 to the negative 2, x to the negative 5, and Aurora, notice y to the 0 is just going to be 1. Excellent. But now we cannot have negative exponents, so how do I get rid of those? Nick?
Make it a reciprocal.
Good. So flip it over the fraction. So we're going to move this 3 to the negative 2 down, move this x to the negative 5 down, and what are we going to get?
1 over 3 to the second power times x to the fifth power.
Perfect. 1 over 3 to the second power times x to the fifth power. Now, we're super close to finishing this problem. There is something else that we can simplify.
So 3 to the second power can become
Very good. 3 to the second power is just 3 times 3, which is 9. So this is 1 over, yeah, go ahead, Brady. 9x to the 5th. And then we're done. All right, one more. Oh, no, just kidding, okay? I'm going to give you 3 more. They should be very easy, okay? But we're going to do them together. Write these down. We've got 1 over x to the negative 3. We've got 2 to the 0 times 4 to the negative 1. And we've got 3 negative 3 squared. 1, 2, 3, go for it. What? Yeah, these are just additional examples. Way positive. So the first one should have been x to the 3rd power. Who thinks they got the second one? Pedro?
I start off by like putting it over 1.
You put it over 1. So you got 2 to the 0 times 4 to the negative 1st over 1, like that?
The other way around, so it's 2 to the 0 to 4 to...
Ah, okay. That works in this instance, okay? But is 0 a negative number? No. So the only thing you should have moved to the numerator is the 4 to the negative 1st, okay? So it should have been 2 to the 0 over 4 to the 1st, okay? I agree with you for that part, okay? Now what's 2 to the 0, Pedro? 1. And what's 4 to the 1st? 4. Who got 1/4? Nice. Nice, okay? That was the tricky one. And who got negative 3 raised to the 2nd power? What'd you get, Gabby?
9.
Excellent. It should have been negative 3 times negative 3, which gives you positive 9, okay? Did anyone get all 3? Nice. Let's go. Okay, perfect. All right, we are also learning 3 new properties involving exponents, okay? Actually, before we go into those properties, guys, really quickly, okay? Are these two equal and why? Or why not? Amina, what do you think?
They're not equal
They're not equal. Very good. Why not?
because, well, I remember that you said that when it has the base has the base is actually a positive.
Excellent.
Because it doesn't have a base.
Very good. So the base of the first one is negative 4, right? So that means we're taking negative 4 and we're multiplying it by itself. So this is negative 4 times negative 4. What's negative 4 times negative 4? Positive 16, right? Now the second one, what's the base of the second expression? 4. Do you guys see the difference? So technically, this is negative 4 times 4 because only your base is affected by the exponent. So that negative is just kind of stuck on there, okay? So what is 4 times 4? Yeah, so now this is going to be negative 16. Are those two equal to each other? No. And the reason why is because our bases were different. Okay? Huh? Yeah. So let's talk about the next 3 properties, okay? So the next 3 properties involve the product of properties rule, the quotient of properties, the quotient of powers property, and the power of power property, okay? Now, the first one is really easy. Let me show you how they got it from, okay? So let's start with, I need you guys to write this down. Let's say we had 3 squared times 3 cubed, right? Now, what is the equivalent of 3 squared? And don't say 9. Like, let's break it down. What would be 3 squared? Brady? It's just 3 times 3, right? So let's say we had 3 times 3. And what's the equivalent of 3 cubed? Nick? 3 3 times 3 times 3, right? So we've got 5 3's all multiplied by each other. That's the same as what? 3 to the 5th power. What did we do with the exponents? You added them together. So that's the product of powers property, okay? So you add 2 plus 3 and you get 5. So 3 to the 2nd times 3 to the 3rd is 3 to the 5th. Now, so we see where it comes from, but what's the same across all of these? What's the same here? Gio? The base, okay? That is the most crucial part. So I need you guys to highlight if they have the same base and they're being multiplied. All we do is we add their exponents, okay? If they have the same base and they're being multiplied, all we do is add their exponents. So if we had 4 to the 6th times 4 to the 3rd, that would be 4 to the 6th plus 3, which gives us 4 to the 9th. Brady, what's up?
Is there any time where you could add the bases together?
Is there any time when you could add the bases together? No. I'm trying to think. No, there's not. Okay? All right. The quotient of properties, of powers properties. So, if we multiplied, when we multiply powers with the same base, we add their exponents. What do you think happens when we divide powers with the same base? You subtract them, okay? So if they have the same base and they're being divided, we are going to subtract their exponents, okay? So if we had 4 to the 6th divided by 4 to the 3rd, we write it as 4 to the 6th minus 3. So then it becomes 4 to the 3rd. And last one, if we have a power of a power property, okay? So if we have an exponent, for example, 4 to the 6th, and it's raised to the 3rd, right? That becomes 4 to the 6th times 3. We multiply the exponents, and we get 4 to the 18th. That is a power raised to a power, okay? So if you have a power raised to a power of a power, then you are multiplying the exponents, okay? So if you're multiplying powers, you add their exponents. If you are dividing powers, subtract their exponents. And if you do a power to a power, you multiply the exponents. All right, let's apply these, okay? So we're only going to use positive exponents here. Let's start with A. What do you guys think we do for A? Gio. Why? Bingo, okay? So we have the same base, right? What's my base here, guys? 3. So 3 to the 2nd times 3 to the 6th is going to be 3 to the 2 plus 6, which is the same as 3 to what power? 8. Now, we do have to figure out what 3 to the 8th is. So let's write it out. It would be 3 times 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 3. Wow. That's a lot of 3's. Now, I like to break it up. So I don't like to do 3 times 3 times 3 times. I like to just do, this would be what? 3 times 3? 9. This would also be 9. This would be 9. And this would be 9, right? And then I do it again. What's 9 times 9? 81. 81. And then what's 81 times 81? I don't know that off the top of my head, so I'm going to have to write it down. 81 times 81 is going to be 0. Then we're going to multiply 8 by 1 and get 8. 8 by 8 and get 64. So it's 64,000. Nope. 6,561. So your final answer is 6,561. Good, okay, or horrible? Times -4 times -4 times -4. Grace, since you asked in the beginning, should I get a positive or negative result here?
Negative.
Negative, very good. Why?
Because it's
Yeah, excellent. My exponent is odd. Perfect. Okay. So now just do these one at a time. What's negative 4 times negative 4? Positive 16. Negative 4 times negative 4, positive 16. And we still have it left over negative 4. So when we're multiplying these, we have to do 16 times 16. That's going to give me 6. Bring up the 3. 6 times 1 is 6, plus 3 is 9. Bring down your 0. 1 times 6 is 6. 1 times 1 is 1. So it would be 6, 5. Bring up the 1. 256. So it's 1 over 256 times negative 4. If we multiply that 256 by 4, we're going to get 4, bring up the 2. 2 times 5 is 20, plus 2 is 22. 2 times 2, or 4 times 2 is 8, plus 2 is 10. So 1,024. So our final answer is 1 over negative 1,024.
Just to Jurko. I don't think that it's like hard. I just
Brady?
You multiply the exponents.
Good. What property is being applied here? It is multiplication, but what property of exponents? Power to a power, right? We're raising z to the fourth to the negative third, so we're going to multiply these. This is going to be z to the fourth times negative 3. What's 4 times negative 3, peeps? So z to the negative 12th. And we still have to simplify that because we cannot have a negative exponent. Nick? Beautiful. 1 over z to the 12th. All right, and let's do it again for D. Aurora? How'd you get that? Good. So you added 4 and negative 6, and you got 10 to the negative 2, but we can't have a negative exponent. What do I do?
You put it to 1 over 10 to the second power, and then you get 1 over 100.
Beautiful. So we flipped that 10 to this negative 2 because it was a negative exponent, and we put it in the denominator, and then 10 squared is just 100. All right, when you're done with this one, turn these in.